In this video, we're going to look at horizontal and vertical shifts of simple parabolas. We again remind you of the standard form of parabola, y equal to ax squared plus bx plus c. In these examples, we're going to look more at this form, y equal to ax minus b squared plus q. For the simple parabolas, we're going to make a equal to 1. A is equal to 1, and in this case we can have a p value and a q value. First of all, the broken line here is again our mother graph, and if you look at the red graph, which is G, and I compare it to the mother graph, the green graph, I see from A to K is 1 unit, so horizontally we've shifted it 1 unit to the left, and vertically from K to F we've shifted it 1 unit down. Since AK is equal to 1 and FK is also equal to 1, the turning point PQ is given here at F, and that is minus 1 minus 1. So that is our PQ value. This is the turning point of the parabola, which is a very important point. And graphically, we see that if I move 1 unit to the left, it corresponds to my P value that is equal to negative 1, which is less than 0. And if I look vertically, I get my Q value, which is also minus 1, and that is also negative, and that's why we've shifted down. Since we know that A is equal to 1 for f of x equal to x squared, we know now that g of x is 1, and then we say x minus our p value is now minus 1 squared, and our q value is also minus 1. So we can simplify it as minus x plus 1 squared minus 1. Our PQ, we've seen that that is equal to minus 1. Our PQ is equal to minus 1 minus 1, and our A is equal to 1 in this case. Because we said we've shifted F, we did not change F, we just shifted it. Now let us look at the blue graph. The blue graph is labeled H. And again, it is F that was shifted horizontally. We see from A to L, it's shifted horizontally. AL gives us 2, so it is 2 units to the right. And vertically, from L to J, or JL, that's 1 unit. So it's vertically 1 unit up. And PQ, we see PQ is equal to 2, 1, and we see that at J. And horizontally 2 units to the right corresponds to a P value of plus 2, which is positive. And vertically 1 unit up corresponds to a Q value equal to 1, which is also positive. We know that A is equal to 1 because we said we're going to shift F, so we keep the A equal to 1, and then we plug in our P value and our Q value, so we have 1 minus P, which is 2, plus Q, which is equal to 1, and if we simplify that, we get x minus 2 squared plus 1. Again, we said our PQ is 2, 1, and our A is equal to 1, which is positive. So this is just a simple concave graph shifted to the right, to the left, up and down, and the P and Q value tells us what to do. In this case, we are looking at the mirror image of the mother graph. This is our mother graph, y equal to x squared. And this is our mirror image about the x-axis, y equal to minus x squared. We call that f of x. So the purple graph is then the graph of f, just a broken line to show that that is where it is, which is a mirror image of the green graph, y equal to x squared. Normally that will be a solid line. It's just for the purpose of the exercise that I made it broken lines. So S is this orange graph here. So what happens to the orange graph? The orange graph is f that was shifted horizontally how many units? From A to N, or AN, is 3 units. Horizontally it shifted 3 units to the left. And vertically from N to M is 2 units. So vertically we've shifted 2 units down. My PQ is given as minus 3, minus 2, which we can see at the point M here. Horizontally, 3 units to the left corresponds to P equal to negative 3, which is less than 0. And vertically, 2 units down corresponds to Q equal to minus 2, which is also negative. And since we know that A is minus 1 as for f of x, therefore my S is equal to minus, then I just plug in my P value plus my Q value, and if I simplify I get minus x plus 3 squared minus 2. So there's my function. And again my PQ is just minus 3 minus 2. I've got an A value of that. This was my orange graph. From there I've moved it 3 units to the left and 2 units down to get the orange graph. The blue graph here is called T, and that is the graph of F that was shifted horizontally. If I look here from A to P, that is AP is 2 units and PO is equal to 1 unit. So horizontally it was shifted 2 units to the right, and vertically we've shifted 1 unit up. 1 unit up. PQ is equal to 2, 1, which can be seen there at the point O. Horizontally 2 units to the right corresponds to a P value which is equal to plus 2, which is positive. And vertically 1 unit up corresponds to Q, which is equal to plus 1, which is also positive. We know A is negative 1 because we said it is f of x that was shifted, and therefore my T of x will be minus x minus my P value is plus 2 plus my Q value is plus 1. And I've just substituted for the purpose of explaining. We don't have to do it so complicated every time. Minus x minus 2 squared plus 1. And then here again, the PQ value is just 2, 1, as can be seen at the point O there, and my A is negative 1. So I've just taken this purple graph and I shifted it 1 unit up and 2 units to the right. We can then summarize for all A unequal to 0. Remember, we're just dealing with quadratic equations here. If P is positive, then the parabola shifts P units to the right. If P is negative, then the parabola shifts P units to the left. It goes with the sign of P. If Q is positive, then the parabola shifts vertical Q units up, and if Q is negative, the parabola shifts vertical Q units down. It also goes with the sign of Q. And that deals with vertical and horizontal shifts of simple parabolas.